everyone, it's Judy Warner. Welcome back to the OnTrack podcast. We're happy to be with you today, and we are bringing to you another sensational guest who is Chris Denney, the CTO of Worthington Assembly. Today, we're going to talk about 5 areas that are Chris's pet peeves, but things that you can do as a design engineer to make life so much easier for yourself and definitely for Chris. So lean in, enjoy. I'll see you on the other side. Welcome to Altium's OnTrack podcast, where we talk to leaders about PCB design, tackling subjects ranging from schematic capture all the way to the manufacturing floor. I'm your host, Judy Warner. Please listen in every week and subscribe on iTunes, Stitcher, and all your favorite podcast apps. And be sure to check out the show notes at altium.com/podcast, where you can find great resources and multiple ways to connect with us on social media. Well, hey, Chris, thanks so much for joining. It's always good to see you. I feel like we've spent way too much time on Zoom this year. So
that is an understatement. Yeah, for sure.
Yeah. Well, it's always good to see you, my friend. So why don't we start out and give our listeners a sense of your background in the industry and what you do for Worthington, and then tell us a little bit about Circuithub as well.
Yeah, sure. So I got started in this industry kind of serendipitously. I was 16 working at a grocery store, and my buddy was working at this electronics manufacturing company in South Jersey. And I didn't really like working at the grocery store. So he's like, well, they're hiring here. So it's the classic story of like show up and put a board on a bed of nails and wait for the green light. Right. And that was sort of how I got started. I kind of liked it. I kind of enjoyed it. I hit it off with some of the engineers at the company, and they encouraged me to go to school for electronic engineering. So that's what I did. And then afterward, I graduated and went to work for an AOI company in your neck of the woods in Carlsbad, California, called the S-Tech. Oh, cool. And that was just the most unbelievable experience for a young kid to, get a huge exposure to the industry and the country and the world, really because you travel internationally a little bit with them. And it was just an awesome experience. But what was really cool about it is I got to go to all these different manufacturers and all these different OEMs and CMs. And I got to see everything from your big giant, Panasonic automotive factory to, your little mom and pop six people that immigrated from India doing their best to survive with a pick and place machine and a reflow oven. It was so cool. And then after that, traveling was a little tough. I was newly married and I wanted to be home more often. So I got a job with a manufacturer's rep firm in New England. And that was a really cool experience too. So now I got a chance to sort of sell equipment, and I got an incredible exposure to all the technology in this industry. Just think of your stencil printers, your pick and place machines, and ovens, waves, selective soldering irons, solder chemicals, everything it takes to assemble a circuit board. That was a really, really educational, forget college, just be a manufacturer's rep for a few years and you've got yourself quite the education. Mm-hmm. I absolutely love that. That was a really cool experience. However, I did it I think I got the job in 2008 and nobody's buying equipment.
Terrible timing.
Oh, it was terrible. Great education, but terrible timing. I couldn't make any money doing it. So I left the firm for Worthington Assembly. They were small and we still are small, but I think there were 10 or 12 people at the time, and they were looking for somebody with kind of a technical background. And they had just bought the company. The owners, Neil and Rafal, had just bought the company. And it was, I liked working with them, as a customer of mine. And I was like, I think we can make this work. So here we are. April will be 10 years I've been at Worthington Assembly. Yeah. And I want to say roughly 5-6 years ago, I got a message from Chris Gammel, which I'm sure a lot of listeners are familiar with Chris from
Amp Hour.
Amp Hour, thank you. which I was a guest on, and here I am forgetting the name of, the name of the show. He said he knew this guy, Andrew, who was looking to start up this company to make circuit board ordering easier. And it was called Circuithub. And Andrew gave us a call, and we liked what he was working on. He flew out at the time. I think he was living in California. He might have been in the UK by then, but I think he was living in California at the time. He had just gotten out of Y Combinator, him and his business partner, and they came out and they like spent a week just like watching what we do and figuring out how to help us automate it. And it was really, it was like, wow, these guys are serious. You know, this is no joke. And then here we are, this, you know, I don't know, 5-6 years later, we're still great business partners with them.
That's great. So, and I'm sure you grew just a tad during that time.
Yeah, just a tad. I mean, double, right? Like not an enormous amount. I think we're probably 20. Well, Worthington, I should say, is about 25 people. I think Circuithub has grown substantially larger. I think they're even more employees than us now. They're probably close to 30 people or so. So if you think of, because the two companies, Worthington and Circuithub, work so closely together, we often kind of think of ourselves as one company. So in some ways, we're almost like 50 something employees, and it's been a wild ride. It's been an absolutely stressful and just this business is so stinking hard. I don't know why anybody does it.
It is so hard, especially the assembly side. It's super hard.
All you do is make solder joints. How hard could it be?
Oh, yeah, right. Same goes for circuit boards.
Yeah.
Little green squares.
That's it.
That's
you're just drilling stuff and just
it's fiberglass.
Putting stuff in a chemical bath. How hard could it be?
I know. I always say we're like Rodney Dangerfield. We get no respect, you know.
You get no respect until you find a CM who's had a bad experience with a board fab, and then they find a good one. Then you get a lot of respect.
Yeah, it's so true. Well, I can relate to almost every aspect of your story. Now I know why we get along so well. Sure. I always say most people I know didn't get an industry on purpose.
That's right.
So I did the same thing. My first board shop was like, a friend of a friend, but then I fell in love with it because of diversity and it was changes of it. And the other thing I say about being on the manufacturing side of the industry is you go on the coolest field trips on the planet, right?
Yeah.
And you do get to travel, and every day's new.
I knew whenever I had to go to a place and show up with my passport in the United States, I knew it was going to be an interesting experience. It was
going to be a good day, right?
Yeah. If they need to verify that, like, not just that, driver's license, they need to know like detail, and they need to spend like a week before I can visit doing a background check. I know it's going to be an interesting tour. That's for sure.
I had a couple experiences like that with Lockheed, the Skunk Works division of Lockheed, and also in situ that makes naval drones in the middle of, seems like nowhere along, I think it's the Columbia River in Oregon. And they launch naval drones off the back of aircraft carriers, and it was a major ordeal to get in with the passport.
I bet.
But so I relate to all of that, and yes, to the hard, and that's why, I use a lot of hair color to cover up all the gray hairs I got over the years.
I'm pretty sure when you go to the guidance counselor's office, they probably breeze over PCB fab and assembly. I don't think that's a really primary section of their book.
No, does not come up. I swear we stumble into it. Yeah. But we like it, and it's interesting, and it's not for the faint of heart, but I share your excitement and passion for the industry. And yes, to the hardcore education you get along the way. Mm-hmm. So for our listeners, I'll make sure and put a link to Worthington and Circuithub below. They do a lot of like NPI, rapid prototyping, and they do it in a really easy way. So if you need to get out a quick prototype or whatever, that, it'd be good to know, Chris, and have those two resources. So I'll throw that in the show notes.
We don't do everything, but what we do it really, really well. That's what we like to say. Yeah.
So, well, Chris, you were talking about Chris. I never know just say Gammel or Gammel.
I've always said Gammel. I've never, I don't know. He didn't correct me when I called him Chris Gammel. Let me put it that way.
Okay, well, Chris, I know, is very involved, not only with the Amp Hour show, which is a great podcast that I listen to from time to time, but also he's heavily involved with KiCad.
Yeah.
And he helped them kick off their first KiCad conference a few years back. And I know you had a chance to speak there, which is where I think we're going to pull this podcast ideas from, is you had 5 areas that were like super well received there that I thought we'd like to share with our listeners today, and hopefully give them some tips on how to make the process easier, faster, cheaper, just better all around. And so
I hope so.
Let's dive into those. So tell us about.
It's evergreen material.
I hope so too. So tell us about how you came up with these, and then let's just dive in.
It was like so Chris reached out to me and he was telling me, hey, we're going to have the inaugural KiCon. Would love to have you give a talk. And it was shortly after I was on the show, and I'm like, oh yeah, I'd love to do that. And then, that experience where you agree to do something and then you're like, oh man, now like I have all this work I have to do.
Yeah.
So I just started literally, like brainstorming, sheet of paper, what can I talk about? And what I came up with was basically, where do problems come from in a board assembly? So like, why do you get boards back and they don't work? And sort of where did that break down? And what sort of struggles do people have in order to make things a success? Because you just want it, like we want it to work. Like it's not like we're trying to like gouge you for every nickel we can and deliver nothing. Like we take pride in what we do. We want the boards to work for you. So where do we get hung up and where do we struggle a little bit? And that's when I started writing some things down, and I wanted to keep it nice and tight. And so I picked these kind of 5 categories. And ultimately at the end of the day, it's things that just kind of, it's not just how do we make it work, but how do we make it work and make it work quickly? Because that's kind of our key thing is how quickly can we get these things done and get these things done right the first time.
Right.
So do you want me to list the 5 things? Or?
Well, let's just hit them one at a time. Sure. And for our listeners, I'm going to tell you that Chris is going to go into these. In the interest of time, we're not going to go real deep on each one. Sure. I think we could talk a lot on each one of these, but never fear. We could spend
an hour on each one probably.
Yes, exactly. So we're going to go over them so you guys have some takeaways, but never fear, because I'm going to link to his full presentation below. So just as way of sort of setting the stage here. So, okay, number 1, what is it? The bane of your existence. Or is that not number 1?
Number 1, no, it's number 1. It's absolutely number 1. And it's even called out in the talk that it's number 1, is identifying the polarity of your component. So I know this sounds crazy. I don't know why it should, but it's something we spend so much time on it. So I mentioned earlier, we're a small company. We're 25 people, and that's including management. And yet we're doing like literally hundreds of unique assemblies per month. And that doesn't include like double-sided. So I don't know, if you 300 maybe, if you include the opposite side of some assemblies. So that means we're just constantly verifying the first piece we build. Like the first piece we build, we're constantly verifying it. And we need to verify that we put all the parts down in the right direction. Like obviously we can tell if it fits, that's simple, but like how do we know that we put it down in the right direction? And you wouldn't believe the sort of like forgetfulness of identifying polarity on a circuit board. And so the process is like we do like 3 checks. So we do it while we're programming our equipment. We do it after we've actually placed the parts, and then we also do it in our AOI machines. So like we're checking this 3 times. The easier it is to see what polarity, what direction this thing is supposed to go, the easier our life is going to be. So there's a woman at work who actually we interviewed on our podcast. We can talk about that in a minute, but she's in inspection and she had a pet peeve about polarity indicators. And she said, put your polarity indicators outside of where the part is going to go. So if you put it in the Silkscreen, if you place a part, I still want to see your polarity indicator. And it's this sort of like, I don't know what you want to call it. In lean manufacturing terms, we would probably call that a poke yoke. It's the idea that you can't make a mistake because you can see the polarity indicator very clearly. The more clear and simple and obvious you can make it, the better. I go one step further when I'm in Altium, and I will make my pin 1 like an oblong, I'll round the corners of my pin 1 and make all my other make all my other signal pins rectangles.
Oh,
so not only is it in Silkscreen, it's also in copper. Like you can't screw this up.
Gotcha.
Yeah.
Now, again, not a designer, but typically standard practices isn't pin 1 upper left. Typically, but that can be.
It depends on the part, like what if it's an LED, right? So now, like, how do you draw your LEDs? Do you draw them vertically? Do you draw them horizontally?
Gotcha.
IPC keeps flip-flopping how they want you to, consider 0 for your pin 1. That if you look at the IPC spec over the years, they've changed from horizontal to vertical. And so how do you identify the polarity on your LED? That's something, the amount of time your CM spends figuring out the polarity of your LEDs, it takes time to figure out the polarity of all your other ICs and your QFNs and blah, blah, blah. We can figure all that out though. LEDs are the worst. They're the worst. They're the most non-standard, non-specific, you're just constantly looking up data sheets. We finally said we had to just say, forget it. If it's a 2-pin LED, we're testing every one of them. We're going to see how it lights up. Then we'll be able to know which end is the cathode, and that's it, done. But then you have vendors they'll mark their anode on their LED rather. It's like, oh.
Well, and I was talking to Dwayne Benson about how he notates those, and he said, yeah, disaster. So, yeah. What else? I like your idea of making this sort of oblong pin 1, so you have a visual reference in addition to the Silkscreen, right? So what else can design engineers do to make it that better?
For polarity? Yeah, so the more documentation you can give. So let's say, for example, you have we get a lot of designs, they don't want any Silkscreen, right? They don't want it to go through the Silkscreen process. They either, usually it's not a cost thing. It's not expensive to do Silkscreen, but maybe they want to save money on that. But most of the time it's kind of like an IP thing, or it's really often more of an aesthetic thing. They just don't want to see it on the board. And so drawings, some kind of, generating, I think Altium kind of has an automatic export for I forget what the document is called, but it's like an assembly drawing that basically shows you all your pin 1 indicators and everything on it. Those things are helpful too. Just the more information, the better. Just
So
give us all the information.
Over communicate.
Yes.
Okay, good. Okay, that's a good one. Okay, polarity. All right. What's number 2?
So kind of related, but it's Silkscreen legibility. So one of the things that we oftentimes run into is customers will get something or they'll send us something and our board fab says, well, we're going to delete all the Silkscreen because it's unprintable, or they have to expand all the Silkscreen. And it's more of a fab issue than a board shop issue.
For sure.
Assembly issue.
Yeah.
But if we can't clearly see what your pin 1 indicator is if you're using Silkscreen, or we can't clearly see what your reference designator is, it's not that we can't get it done, because we can still go back and we can reference the data, obviously, right? We'll figure it out, but it's just making things harder, right? Again, is it possible? Yeah, of course it's possible, but it's just that much harder. It slows things down. It makes it that much more challenging. You don't want to be that customer that every time you place an order, your CM just goes, oh no, not again.
Right.
Because we get those customers, it's like, oh, do we no, oh gosh. Can we raise the price? Can we price them out? One of those.
You know
situations.
what? To our audience, that seriously happens.
Yeah.
When you become a persistent pain in the rear, that really happens. So
Yeah.
be aware.
Yeah.
And it's a time to market issue. If you have to stop and check the data or make a phone call, slows things down. So yeah.
If you're more expensive for the CM, they're gonna have to charge you more. As a matter of fact, well, with Circuithub, it's all electronic, so we can't fudge the numbers there. It's just
right.
The price is agnostic. But with our internal customers, we use a platform called CalcuQuote. I'm sure.
Oh, I know the guys at CalcuQuote. Yeah, that's a cool.
They actually have a field. Like when you click the drop down to select your customer or whatever for your quote, they actually have a field in there for like how much like fudge factor do you put in your quote? Basically, how much are you going to overcharge this customer because they're a pain in the neck? And you can leave it at 1, or you can slide.
That's funny.
So it's a real thing. Like it legit happens, and we'll see it too because we're a customer for people, right? For
right.
Parts and for boards. And if all of a sudden every time we send a quote to a board shop, like the prices just seem astronomical, we go, oh yeah, something's bad here. Either they're way too busy, which I like to think that we're not that much of a pain for our board shops, but they're either way too busy and so they have to just keep increasing prices because otherwise they can't keep up or whatever, or we're a pain in the neck and they don't want us to be a customer anymore. I mean, yeah. Truth revealed here.
Truth revealed. Spoiler alert. No, it really does happen. I don't think a lot of design engineers realize that there's some invisible costs that you may incur, if you're not careful with these things, just because it actually costs more. It's not just because we're going to punish you because we don't like you. It takes more time and you have to recoup. The margins are thin. So we can't eat up all our own margins to do that. So totally get it.
It's crazy because you're building a board and you're charging like $20 labor and you're buying $1 million worth of machinery to build it. It's like I don't understand how we make money.
I know. It's true. Okay. And Silkscreen, by the way, is made with the Silkscreen and it's not perfect. You're basically squeegeeing on this sort of nomenclature, but then all of a sudden your B's or become D's or your R's become B's, and it's really hard.
I have like specific numbers.
Well, you do? Well, there's different ways of applying now too, besides the Silkscreen.
Which you could do a screen or you could do the ejector thing.
Yeah, what is it? I forget what the technology is. Is that what it is? Like an inkjet. That's what it is.
It's basically like an inkjet, but there's a term for it. My board supplier will always tell me, do you want to use this or do you want to use that? And when cost is everything, it's inkjet. But when, maybe you have like a really cool logo on it, like we've done work for, some high-end brands and stuff, and the brands they like their logo to look really nice. So
really sharp.
Make sure you use the Silkscreen, not just the ejector. But the size of I find that, because this was kind of informed from my own work doing PCB design, but also my work doing manufacturing, that I find that there's like a cozy spot of how big you can make your reference designators and your text. Like line width, like a cozy line width is somewhere around, I apologize, I only know metric because that's all I work in, but it's somewhere around like 0.18 to 0.2 millimeters line width. It's like a nice middle of the road. It's nice and small still, but it's super easy to print and really easy for, the board shops to lay down, and it'll look really nice. It'll come out really good. And then your text size, I just found 1 millimeter by 1 millimeter is, and if you can fit all that on your board, maintaining those sizes, it'll be legible and we'll be able to see it. We'll know where everything is. We'll know, like when you say, oh, I meant to have a 10K at R2, not a 4.9K. well, then we can very easily, there's R2, and it's, it's not difficult. Whereas like, okay, now I got to go back to the documentation, find where R2 is. And maybe I have people on the floor that like, don't want to look at the computer. So I got to print this out and I got to have an arrow. And, so I'm going to spend half an hour to write up this documentation. Whereas if it was just very easy to see on the board, you just hand the rack of boards to a person, you say, here's R2, and they just get to work.
Right.
It does make a difference.
Well, that's kind of a handy, good concrete takeaway, actually, to give the dimensions. So that was a nice little goodie there.
There you go.
All right, let's go. What's number 3, Chris?
All right, let me find my notes again.
We'll cut that part out.
Yeah. So panelization, knowing that panelization exists. So I would imagine if you're the type of person who's listening to the show, you probably know that panelization exists. Like this isn't a shock to you. But like, don't order your boards and then expect your CM to just build them. Like that has so rarely worked. So rarely worked for us. We've published documents on our website that say, okay, if you insist, you absolutely insist on supplying boards to us and you don't let us order them for you, then you have to meet these guidelines. These are our expectations, because remember, we're building these things with machines. And so you got to clamp these boards in a machine, and you have to have visual reference indicators that tell the machine where the heck the board is inside the machine, called fiducials, which I'm sure your listeners are probably familiar with the word fiducials. Funny story real quick. The first time I heard the word fiducial, it was that first CM I worked at when I was 16. I'd worked there through college. And while I was in college, they thought, hey, maybe we can show the kid how to build our library for, I think they were using like one of those massive, I don't know if it was Mentor Graphics or one of these massive, companies. And the guy goes, oh, okay, well, here's our library of discrete components. Here's our library of ICs. Here's our library of fiducials. And I like chuckled, and I'm like, oh, is that an industry term? And he's like, yeah, I guess. Yeah. I don't know. And I thought it was like a made up word. Like, I thought it was like, like hazing the new guy, Yeah. I remember working with my dad and we're building a extension to or not an extension, but we're remodeling a section of our house. And my dad goes, okay, I need this board cut to such and such. And of course I cut it like half an inch too short. He's like, oh, don't worry about it. Go out to the truck and get the 2x4 stretcher. What's it? Just, you'll find it. You can't miss it. Go out and get the 2x4 stretcher. Of course, there's no such thing. That's hazing the new guy. So I thought for sure that these engineers are just hazing me with this term fiducial. Apparently it's a real thing. Yeah.
It's a real thing.
It's a real thing. But anyway, so back to panelization, the point of this discussion here. Panelization exists, and importantly, usually your CM will panelize it for you. That's not something you normally have to worry about. If you like to control that, great. That's fine. Just make sure you meet your CM specs and everything. But usually they'll control that for you, and they'll work with their board shop to get just the right panel size that they want, something that works for the board shop, something that works for the CM. And that's important to know too, because the board shop has a limited size that they want to maximize their panel usage and everything.
Just fun fact here, which I'll throw this in the show notes too. I did a podcast with Kelly Dack and on panelization. And he said he works for a big CM up in Washington area. And I'm like, I know he sees stuff all the time. Like, what's a hot topic you want to talk about? He goes, panelization. I was like, really? That podcast took off. It got a lot of traction. So I'm going to throw that in the show notes.
Please do. I want to listen to it. Make sure you get me the link to
that. All right. Done deal. All right. But continue.
So the reason that panelization matters as far as your CM is concerned is because like one area in particular that is always neglected. Now here's something that, so far probably a lot of people are just nodding along and it's a bit of reinforcement to their own knowledge. But here's one thing that I find a lot of times when I talk to designers, they don't even realize is an issue. We need to know when parts are hanging over the edge of your board. So we need to know if you have some potentiometer sticking out the edge or some USB connector or, Bluetooth antenna. We need to make sure, or right angle connector. We need to make sure we have room when we panelize these things so that it can hang over and we're not hopping on top of an adjacent board. And, I love Altium designs because a lot of times there's like 3D models built into them, so you can see things hanging over the edge. But maybe this is, some kind of proprietary part and there's no 3D model for it or whatever. Just give me the silkscreen outline. Just show me where it extends to. Do something to show me how far this goes out and where it goes. And then I can work on the geometry to panelize this and make sure that we don't, I can't tell you how many times I would say at least once a week, we get a panel where things hang over and it's like, okay, well, how are we going to build this now? We got to break them apart and we got to do all this Mickey Mousing with tape and holding stuff together. And it's a mess. Yeah.
Yeah. Well, and I remember when you were part of the open source ventilator project that we've shared extensively here. And I remember that was one of the issues that you guys flagged, using Altium 365 and having the 3D, you were able to go, stop you guys. And they're like, oh yeah, I would have never known that. And so it was a great catch. So yeah. I've heard you talk about this issue before.
the micro USB port. That is probably my biggest personal pet peeve. It's not like every CM's pet peeve, but it's my personal one, the micro USB port. I love USB-C. Just use USB-C and be done with it.
That's funny. Okay, good. What's next? What are we on, number 4 now?
Yep. So we actually, because we order 99% of all the boards for our customers, take the time, give yourself a nice template and fill it out each time you order a board, or we have templates on our website. You can just use our own if you're requesting a quote or using Circuithub to request a quote. There's a whole built-in form that you should fill out for the properties of your PCB. So I can't tell you how many times, customer, ordered boards and told us that it's 1.6 millimeter. Oh, it turns out I needed 0.8 millimeter. And it's like, okay, well, we just spent, $6,000 flushed down the toilet here, really take your time to know what you want in your PCB, what TG material, or TG, is that a rating or a material? You would know.
Yeah, no, it is TG. It's the
thermal rating, right?
The thermal rating, thermal to glass.
Yes.
So,
So what TG rating, are we just using standard stuff, or do you want the 175? Is 130 okay? Do you want to save the money? Do you want the higher reliability? Board thickness, board color, silkscreen color. Do you have impedance control? Give us as much detail about the PCB as possible. Don't assume that we are going to use whatever. Take the time to get this right. Yeah. And
yeah.
Because it breaks our heart when we build these things and then the customer says, I needed a blue silkscreen. And we did that once. We had a customer, they make hobbyist, not brain control, but what do you call it? Neuroscience, hobbyist neuroscience, educational kits for neuroscience for kids and stuff like that. And it kind of you hook this up to your arm that you hook it up to your head and then somebody taps a button and it flexes your arm and all this kind of weird stuff. But anyway, so they wanted red. I don't remember the exact colors. Let's say they wanted red. Well, they accidentally ordered yellow. And we built, hundreds of these for them in yellow. And they were like, we can't use these. It's off brand because our brand is red,
Oh boy.
And I'm like, maybe a special edition, yellow, maybe you can make it a premium product. No.
Well, here's my thing. Here's my old, my veteran rant about this. We used to have this little thing called a flippin' fab drawing.
Yeah.
Where you'd have all of that indicated. And I don't know how I left the industry for a while and came back and fab drawings had died. And people would just say, they'd send us the files, the Gerber files, and a README file that had 4 things on it.
Yeah. Or they'll just say standard specs. And you're like, ugh,
yeah,
okay.
And it's that. Yeah, that is just asking for trouble because it's basically the blueprint of what you want.
Yeah.
And in the absence of that, it's really bad. So I think we have some cool things inside Draftsman, inside Altium Designer that you can make actually a really good fab drawing.
Yeah,
I wrote a blog about this one
right.
time. I wrote a
Link to
blog
it.
about this. I'll see if I can link to it. It's old, but it was about this, and gosh, I probably wrote it 8-10 years ago, but it was like, for design engineers, please make a fab drawing, because, and then I put in an old link, but like, here's what a good fab drawing looks like. And it was just funny. Like, I felt like, I can't believe I have to say this, but
Right.
I think when we all shifted to digital, back in the day, I used to carry physical blueprints and physical films. And I think once we migrated to digital, it just got lost along the way. So it's a really good point. Okay. Last one.
So last one is specific manufacturers' part numbers. And the theme with all these things is like, we can get there, we can get the board built, but if you want it built quickly and right the first time, these are the 5 sort of tentpole things that we run into. And a lot of times customers don't take the time to really think about the part numbers that they specify. They may put into their Altium document or Altium properties for that location 555C. And it's like, okay, well, do you want, like the BGA 55 timer, or do you want the SO8 555 timer, or do you like, which one do you want? Like, we need the full specific manufacturer's part number.
My friend always says there's no such thing as approximate part number.
Yeah, half part number, or
yes,
family
yes.
part number. That's a good one.
Yeah,
No, full part numbers. And even for like 10K resistors and whatever, because a lot of times customers will just want to put like 10K, 4.9K, 0.1 mic, 0603. And it's strange because every time we say, well, can we have a manufacturer specific? And the common question or the common response is, well, whatever you have on the shelf. Don't assume we have it on the shelf. Just tell us what you want, and we will order it if we don't have it, or if we do have a common cross, then we'll say, okay, we don't want to order it. We have this cross. Can we use this cross? But in order for speed, if you want this done quickly, full manufacturer's part number. And that way there we just hit the ground running. The other reason is, if you give us a full manufacturer's part number, that gives us the full spec. So maybe you say 0.1 mic 0603, but you really don't want an X5R. You really want an X7R. Maybe this is going to go to some scientific instrument that's going to study something in Antarctica. And so you need the extra thermal stability of that cap or something. We don't know. So if you just say whatever, then you're going to get a 6-volt X5R. You're not going to get your 50-volt X7R or something like that, So the manufacturer's part number gives us all the specific details we need, and more importantly, in my opinion, we hit the ground running quick. Like, There's no delay. We just start on your project.
And for most CMs, I don't know about Worthington, but most CMs, the last thing they want to do is stock parts. I mean,
no. We do not want to stock parts.
No, it's expensive.
Yeah.
So I, to the audience, I wouldn't ever assume, even if it's something as simple as, common parts, resistors, caps, whatever, they don't want to stock any of that. The margins are thin. They want to order them and do the sort of just in time model. And that helps them extend the best price to you. So
that's right.
Yeah.
Yeah. I mean, we'll stock when customers want to send us parts, we had a customer send us like 300 of these Intel FPGAs. They're probably like, I don't know, $1,000 a piece. Yeah, we'll stock them for you. We'll take very good care of these parts.
Right.
But I am not going to worry about a 10K Panasonic 0603.
Exactly. Yeah. So I think most people understand it, but just thought it was worth mentioning for those newbies out there.
Most of this is probably just people nodding along like, yes, I've learned this, and they're probably remembering that experience where they learned this, when they learned this, that, their manufacturer doesn't want to stock a 10K resistor. But, I like to think that if you're listening to a show like this, you're trying to educate yourself. And if you know all this already, but you're working with a junior engineer, make sure he listens to it or she listens to it.
Yeah, for sure. I think it's a really good point.
Can I throw in a bonus?
Yes.
Six pet peeve.
Yes.
Hole sizes, plated through hole sizes. Calculate your plated through hole sizes properly. Don't just assume that the library you pulled down from the internet is going to have the right through hole size. I can't tell you how many times we struggled to insert a part, and because the specification was a 1 millimeter hole, or the specification was 1 millimeter lead, and so the designer just put 1 millimeter hole. It's like, this is never going to fit.
Yeah.
The plating buildup and all that kind of stuff.
Mm-hmm.
So you can find there's probably a million plated through hole calculators out there. It got to the point where we were seeing it so often that I wrote a blog post on our website with how do you calculate your plated through hole size for circle, square, and rectangle. And we get it so often that, we send these emails to customers at least once a week. Like, here, if you want to know how to do it, here's this, here's this, here's this. Yeah,
okay.
that's
so I will, since we're putting the link below, I'll make sure that people have that link to the blog too, so they can go get some good information there as well. That's a good one, because they don't realize as we plate holes on the fab side and it closes down the hole.
Mm-hmm.
So you don't want to drill it at that dimension, and then it gets plated down, and then we got a big problem at Chris's place.
Exactly. And maybe you don't realize it, but there's actually 3 different specs according to IPC of how much extra range you give. Like, if your part is such a diameter, how much wiggle room do you give that hole size? It depends on what you're trying to build, but you may not want to have it really small. You may want to give it extra room, and you can have greater hole fill and greater bond strength with the solder, and yada, yada, yada. So there's actually quite a bit to it.
Yeah. Yeah. These things that seem so simple on the outside, but it's all good stuff to know. Well, thanks. I loved it. I loved your list. And as I said earlier, we'll make sure to link to all the stuff to your full talk. Isn't that funny? It was so well received, Chris. We think about these things all the time, and we're not. Yeah. But, there's so many new engineers. There's people that are designing boards that weren't designing boards before. And so there's always
maybe they were just doing the schematic before, and then the layout guy got laid off, and now they got to do the layout.
And they're just thrown in the deep end of the ocean to figure it out.
Yeah.
Well, you can't just Google it. So to our listeners, Chris also has a podcast. So we're going to plug you into all the resources. You continue to learn more through the Worthington website, Circuithub. You can go to their blog, listen to his talk. So there's much more here. We just sort of gave you the appetizer. And then Chris's podcast is called the Pick Place Podcast. Yeah. I'll put a link to that.
And if there's one thing I can just say about it, if you get nothing out of this conversation, I hope you subscribe to it, because we have a lot of fun with it. And we break down each process in the manufacturing, like what is stencil printing and what does it take? What is pick and place and what does that take? And that's been a lot of fun to kind of pour that out and get it out of my head and get it into listeners' ears. And I hope it's been helpful. We've gotten some great feedback on it.
Great. Well, I love it. I think this is a really good, something you can do almost passively. If you're driving or whatever, you can listen to a podcast and educate yourself. And so, well, good luck with the podcast, my fellow podcast host.
That's right.
And so I will also put the link to that before, so people are listening here can subscribe. Also, Chris and I and a design engineer and Jerry Partita, who's from a fab shop, we did a panel together on basically designing with manufacturing at Altium Live this year. And that recording is available on YouTube. I'll put that link below too. So there's lots of goods in the show notes. So I really encourage you. I hope you enjoyed this, but we're going to put a ton more resources in the show notes. So please go check it out. And Chris, thanks so much for joining. It's always great to hang out with you.
Yeah, thanks so much for having me, Judy. It's a lot of fun.
So again, to our listeners, thanks so much for joining us. And we will see you next time. Please remember to like and subscribe, because that's how we know what you're engaging with and how to continually serve up great content. So thanks for joining us today. Stay healthy, stay safe, and always remember to stay on track.